Alright, so these are video notes for section 6.8. We're going to start off with a warm-up, a situation that you may have encountered before. So we have this situation where we have Allie, John, Bob, and Susie enter a race. First and second place will be awarded. So how many different arrangements of first and second place are possible with the four runners? Okay, so the order does matter here. We want to know who's in first place and who's in second place. So let's say that in first place is Allie. That means second place can be John, Bob, or Susie. So if Allie's in first place, there's three possible combinations of first and second. If in first place we had John, second place could be Allie, Bob, or Susie. If Bob is in first place, then second place could be Allie, John, or Susie. And if Susie's in first, second could be Allie, John, or Bob. Okay, so if we count this second row here, that's going to give us the total number of cases, which is 3, 6, 9, 12. So there should be 12 possible combinations of first and second place, where here, John being in first and Allie being in second is a different case than Allie in first and John in second. We're considering those to be two different things. So we're going to call this a permutation, which is a combination of possibilities where the order does matter. So it matters who's in first and who's in second. Those are different cases. Okay? Now we're going to talk about, there's a way we can do this on our calculator, and this is using our probability functions on our calculator. So there's two ways that we can write this. One way we can write this is NPR, where N is the number of choices and R is how many we choose. So again, N is the number of choices and R is how many of those we're choosing. So in this case, we're going to take 4 as our number of choices. There's 4 people. And R, how many we're choosing, that's first and second place, so 2. So we have 4P2. Now, on your calculator, we're going to calculate this by going to Math. So you're hitting the button that just says Math, going all the way to the right to PRB for probability, and option number 2, you see it says NPR. That's how we're going to put it in, but we need to put in that 4 in front and the 2 behind, like we have it written here. So I'm going to quit and type in 4 in front, then go to Math, probability, 2 for NPR, and for the R, I need to have a 2. So again, 4 for the N, 2 for the R. So the 4 and the 2 are in front and behind. If I press enter, you can see that that also gave me 12 total possibilities. So you can write this as equals 12. Right? So that's a permutation where it matters what order we choose our choices in. It matters who is first and who is second. Okay? So let's look at a second example in number 2. We have the same 4 people are running for student council and only 2 will make it. So how many ways can we choose this 2 students out of the 4? So does the order matter here? No, it does not. So I could have Allie as my first, and then John, Bob, or Susie as my second. Another possibility will be John, but we've already done Allie and John. And Allie and John, it doesn't matter what order we pick them in. So I already counted that, so I have John and Bob, or John and Susie. And then last, we've already done Bob and Allie, we've already done Bob and John, so we need Bob and Susie. So here we have 1, 2, 3, 4, 5, 6 possibilities. Here we're going to use, instead of a permutation, something called a combination. So a combination, the order does not matter. It doesn't matter who gets pulled out first and who gets pulled out second, or who's chosen first, who's chosen second. We're going to write it similarly as in CR, where N is our number of choices and R is how many we choose. So this time, my N is going to be 4. I have 4 choices, and I'm choosing 2 from that 4. Again, it doesn't matter what order I choose them in. I just have to pick 2. So this is going to be similar in our calculator. We're going to type that 4 first, and then I need to go to math, all the way over to the right to probability, and this time I go down to 3 to end CR, and for my R I have to put a 2. And you can see my calculator gives me 6. This gives me 6 possibilities. Notice there's less possibilities with a combination than there was with a permutation. Okay? Another way of writing this is if we put our N on top and our R on bottom. So in this case, we would write it as 4, choose 2 in parentheses with 4 on top for our N and 2 on bottom for our R. Okay, that means the same as 4, choose 2, or 4 and then the combinations by choosing 2 choices. Okay? So let's get some practice on our calculator. I'll do the first one with you. So on A, we're going to evaluate these expressions. Again, we're just putting them in our calculator. I see the C in the middle means we're taking a combination. 10 is in front is my N, 5 is my R. So I'm going to plug in the 10 first, go to math, right to probability, not too far, and down, oops, I clicked the wrong thing. Let's try that again. In math, probability, and, oh, I did it again. There we go. And down to NCR. That should be a 10. There we go. Okay, thank you for your patience. So we have NCR with 10 for our N and 5 goes at the end for our R. We're going to press enter, and so that's going to give us 252 as our final answer. So this equals 252. That means if I have 10 possible choices and I want to choose some combination of 5 of those things, there's 252 possible combinations. Again, where the order does not matter. Okay? So I want you to try now B and C. Pause the video, try them on your own, and then unpause and check how you did. Alright, so here are the answers for B and C. Hopefully you tried them on your own first. For B, I'm going to type in 8, math, probability, NCR2, enter, I get 28, and I have 25. Taking the combinations, choosing 7 of those choices. This time I get 480,000, no, I'm sorry. Yes, 480,700. Okay, so if I have 25 possible choices and I'm choosing a combination of 7, there's 480,700 possible choices. All right, let's go to the next page. All right, so we're going to talk about this in terms of expanding these polynomials. So we have a theorem called the Binomial Theorem, and it tells us that if we have a polynomial here in factored form where we have a plus b to the nth power, that we can expand it into standard form using this formula where we're going to take the combinations as we go up. Okay? Notice that each time we still have n choices. So n is the number of choices that we're putting in. Again, that came from our exponent here. And we're choosing 0, then 1, then 2. And we're going to go all the way up until we get to n, choose n. Okay? So how we're going to write this is I'm going to start by looking at my exponent. My exponent here is 4, so I'm going to put a little note here that says n equals 4. And I'm going to list this going down. So I'm going to start writing it in parentheses, saying my first term, I'm going to use 4, choose 0. Again, that's the same thing as writing it like this. Then I'm going to use 4, choose 1, 4, choose 2, 4, choose 3, until I get to 4, choose 4. Okay? Now, if I look here at my a's in each term, I start with a to the nth power, a to the n minus 1, a to the n minus 2, and so on until we have no a at our last term. So here I just have a, so I'm going to write a to the, again, n was 4, a to the 4th, a to the 3rd, a to the 2nd, a, and then the last term I won't have any a's. Okay? For our b term, if you look in our formula, we have b to the n as our last term, and then if we work backwards, we have b to the n minus 1. So here we're going to start at the bottom with b to the 4th, and go up and write b to the 3rd, b to the 2nd, b to the 1st, and then again in the top term we're not going to have any terms with b. Okay? So now I can use my calculator to calculate my combinations here. So I'm going to do 4, choose 0, which gives me 1. So my first term is going to equal just 1 times a to the 4th, or a to the 4th. My second term I need 4, choose 1. Which gives me 4, so I'm going to have 4 a to the 3rd b. My next term is 4, choose 2, which is 6, so I get 6 a squared b squared. Next I have 4, choose 3, which is 4, so I get 4 a b to the 3rd. And last I have 4, choose 4, which is 1, so my last term will be b to the 4th. So I can write this all out in standard form, just going from the top to the bottom. We're going to put it back into a horizontal equation. So I have a to the 4th plus 4 a cubed b plus 6 a squared b squared plus 4 ab cubed plus b to the 4th. Okay, so there is my final answer, expanded out. We're making it bigger. Alright, so let's look at example 2. This time we're going to expand c minus 2 to the 5th power. So first I need to see what's my n. My n here is my exponent, so n equals 5. So whenever I write my combinations, I'm going to start with 5, choose 0, 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, and 5, choose 5 will be my last one. Okay? I start by putting in, I'm going to use a and b this time, so we're going to start with a to the nth power, which was 5, so a to the 5th, a to the 4th, a to the 3rd, a squared, a, and no a's on my last term. I'm going to plug in b. I'm going to have b to the 5th on the bottom. Going up, I have b to the 4th, b to the 3rd, b squared, b, and no b's on the top term. Okay, this is always going to look the same. You start with your exponent that matches your original problem. Okay, but now I need to fill in what a and b equal, as well as what these combinations give me as a number. Okay, so let's start by just doing our combinations. You can plug each of those into your calculator, so do that now. Okay, so I went ahead and did all of those on my calculator. You can see here's my last 3 that I plugged in. I got 1, 5, 10, 10, 5, 1. Those are going to be my coefficients in each term. Alright, so what I need to do next is think about what a and b represent. So looking at my equation, and let's compare that to the theorem, we have a plus b to the nth power. So here my a equals c, and my b equals a minus 2. So anywhere I see an a, I'm going to plug in a c. Anywhere I have a b, I'm going to plug in a minus 2. So let's go down our list. For the first term, we have 1, and then we had a to the 5th, so I'm going to plug in c to the 5th for a. Our next term, we had a coefficient of 5. A to the 4th becomes c to the 4th. And b, we're going to multiply that by a minus 2. Our next term, we have 10, and then a to the 3rd becomes c to the 3rd. B squared becomes a minus 2 squared. Notice how I'm putting that in parentheses. Our next term, we have 10. A squared becomes c squared. B cubed becomes a minus 2 cubed. Next, we have 5 times a, which will be c, and b to the 4th is negative 2 to the 4th. And last, a coefficient of 1 times b to the 5th, which will be negative 2 to the 5th. Okay, so now we can multiply these out. The first term will just be c to the 5th. The second, I have negative 2 times 5, or negative 10 c to the 4th. My third, I have negative 2 squared, which gives me positive 4 times 10 is 40, and c cubed. My next term, I have negative 2 to the 3rd, which gives me negative 8 times 10 equals negative 80, c squared. Next, I have negative 2 to the 4th, which gives me 16 times 5. So I'm going to have a positive 80c. And last, I have negative 2 to the 5th power, which is negative 32. Oh, I forgot my c. There we go. Okay, so notice my exponents are still going down. Looks good. Okay, I can write all this out now horizontally. So I start at the top. I have c to the 5th minus 10c to the 4th plus 40c cubed minus 80c squared plus 80c minus 32. So there we go. We have expanded that out completely. Alright, let's look at the next page. Again, if you missed anything, please pause the video and go back. Okay, so we're going to do number 6. Again, using the same idea, my n is my exponent. It's going to equal 6. My a is the first term, which is 2x. I'm going to go ahead and put in parentheses now. And my b is the second term, which here is a minus y. Alrighty, so since our n is 6, I'm going to start with a combination of 6, choose 0, 6, choose 1, 6, choose 2, 6, choose 3, 6, choose 4, 6, choose 5, and 6, choose 6. Alright, and I need to start by putting in my a's and b's. I'm going to put them in as a's and b's for now, and then we can expand it out the next step. So I'm going to start with a to the nth power, which is 6, a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a squared, a to the 1st, and this is a to the 0, or just 1. Now I start with b's at the bottom. I have b to the 6th, b to the 5th, b to the 4th, b to the 3rd, b squared, b, and b to the 0, which is 1. So now, let's multiply those out. Alright, you should be practicing putting these in your calculator, but here are our coefficients. 1, 6, 15, 20, 15, 6, 1. Alright, so now I'm going to plug in what my a and my b equal to match here. So for a to the 6th, I'm going to have in parentheses 2x to the 6th, a to the 5th times b, I have 2 to the x to the 5th, times negative y. For a to the fourth, I have 2x to the fourth times b squared is negative y squared. Again, notice my parentheses. A to the third is 2x to the third, b to the third, negative y to the third. A squared, I have 2x squared, b to the fourth is negative y to the fourth. A times b to the fifth gives me 2x and negative y to the fifth. And I have b to the sixth, which is negative y to the sixth power. Alright, let's expand this out. So remember, whenever you have things in parentheses that are being multiplied together, and it's to an exponent, that exponent has to be distributed to both pieces. So if we have 2 to the 6th power, that's going to give us 64 and x to the 6th. That 6 as an exponent goes to the 2 and the x. For my next term, I'm going to have 6 times 2 to the 5th, or 32, times x to the 5th, and negative y, so times negative y. For my next term, I have 15 times 2 to the 4th, which is 16, times x to the 4th, and negative y squared. That negative is being squared, so it becomes a positive, so just times y squared. Oh, that's better. Okay. Our next term, we have 20 times 2 to the third, which is 8, times x to the third, and negative y to the third. That negative is going to stay, so negative y cubed. Next, we have 15 times 2 squared is 4, times x squared, and negative y to the fourth. The negative will go away here, so we have just positive y to the fourth. Next, we have 6 times 2x times negative y to the fifth. Here it's an odd exponent, so the negative stays. And last, negative y to the sixth. Since the exponent is even, that negative is going to cancel out, becomes positive 6, or y to the sixth. No negative. Okay, let's go ahead and expand this out horizontally, and we can multiply those last few things as we do so. So our first term is going to be 64x cubed minus my next term. 6 times 32 gives us 192 x to the fifth y plus 15 times 16 is 240 x to the fourth y squared. The next one is going to be a minus. 2 times 8 is 160 x cubed y cubed. Next we're going to have plus 15 times 4 is 60 x squared y to the fourth minus 6 times 2 is 12 x y to the fifth, and last plus y to the sixth. So this whole thing is the expanded form of our polynomial. Notice you can look at the coefficient, or the exponents of the x are going down, the exponents of the y are going up. Alright, so let's look at, maybe we don't want to write this whole thing out, we just want to find a particular term in this expansion. So say I just want to find what the second term here is going to be. So we're going to use this formula here that you see below. So star this, put a box around it, so you can refer back to it later. So let's say that we want to find a term, we can call it term t here. Okay? Well, our n is going to be the same depending on what the exponent in our binomial was. Our r is going to be our term minus 1. So, for example, when we do n choose r, a to the n minus r, b to the r, let's say that we want to find the 11th term in a particular expansion, then we're going to use an r of 10, so 11 minus 1. Okay? So let's try it here. We want to find the 4th term in our expansion of 3x plus 2y to the 7th. So our n is going to be our exponent, which is 7, so n equals 7. Our r is going to be the term we want to find minus 1, so 4 minus 1 gives us 3, so our r is 3. Our a is our first term, 3x, and our b is our second term, which is positive 2y. So I'm going to plug it into that formula, which was n choose r, a to the n minus r, b to the r. So I'm going to take 7, choose 3, a to the 7 minus 3 is 4, b to the r, which is 3. Okay? So now I can plug in, just as a reminder, 7, choose 3. We're going to hit 7, go to math, probability, down to 3, and now type in there 3. So I have 7, choose 3, enter. That gives me 35. For a, I'm going to plug into parentheses 3x, and that's to the 4th. And for b, I put in parentheses 2y, that's to the 3rd. So if I multiply all of that out, I get 35 times 3 to the 4th, which is 81, x to the 4th, times 2 cubed, which is 8, y cubed. So I'm going to multiply out that 8 times 81 times 35, and I get 22,680 x to the 4th y cubed. So that will be the 4th term in the binomial expansion of this polynomial here. Okay? So you're just using that formula. Okay, let's try one more. Actually, why don't you try this one on your own, pause the video, and then unpause and check to see how you did. Alright, so here we go. I have my n is my exponent is 9. My r is the term I want to find, the 5th term minus 1, so 4. My a is 2x, and my b is a minus y. So I'm going to plug this in. I have n choose r, so 9 choose 4. A to the n minus r, so n, 9 minus r is 4, that gives me a to the 5th. And b to the r, which is 4. So I plug everything in. If I take 9, choose 4, in my calculator I get 126. For a, I plug in 2x to the 5th, and for b, negative y to the 4th. So I can say 2 to the 5th gives me 32. So 126 times 32 times x to the 5th, negative y to the 4th. The negative going to an even exponent will cancel out, so I just get positive y to the 4th. And 32 times 126 gives me 4,032 x to the 5th, y to the 4th. Alrighty, we have one more page to go here. Okay, so think about if you had to calculate all of these combinations out by hand without your calculator, how much work that would be. Now hopefully you've noticed that there's been a pattern. You saw 1, 6, 15, 20, 15, 6, 1. It started going backwards. So Pascal noticed this pattern and started trying to find a pattern that would work. And so what he did is put it in this triangle. So here's the coefficients with an expansion of 0, an expansion of 1, an expansion of 2, an expansion of 3. Here's all the coefficients, 4, 5, and so on. Okay, so we can actually type these into our calculator. So if we want to find the expansion of a plus b to the 6th, we know the first is going to be 1. The second is going to be 6. To get the 7th, we can plug this into our calculator and take 6, choose 2, and we get 15. Okay? If we take 6, choose 3, we'd get 20, 15, 6, and 1. Okay, and so what you notice is that if you look at a term and look at the two terms above it on either side, those two terms sum to the term below. Okay, so you can see that 10 is the sum of 4 and 6. 6 is the sum of 3 and 3. 4 is the sum of 3 and 1. So he used that so you could actually calculate what these terms are going to be. So if we do a plus b to the 7th, and let's do it using Pascal's method. So if we take 6 and 1, that sums to 7. 6 and 15 sums to 21. 15 and 20 gives us 35. 20 and 15 gives us 35. 15 and 6 gives us 21. And 6 and 1 gives us 7. And our last term will be 1 as well. Okay, so you can double check these with your calculator. These will work also. So we can use the same thing just using this triangle without having to plug it into our calculator to expand these binomials. So let's look at, now that we have done a plus b to the 7th, the expansion of x plus y to the 7th. So we know that our coefficients are going to be, and I'm going to write it going up and down, 1, 7, 21, 35, 35, 21, 7, and 1. Okay, not a lot of room here. I have to squish it all in. And I'm going to take my a term, which is x, start that at the top with x to the n, which is 7, x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x squared, x, and x to the 0. Start with my b term, which is y at the bottom, y to the 7th, y 6th, y 5th, y to the 4th, y 3rd, y squared, y, and y to the 0. So I can write all this out. Going across, I have 1 x to the 7th plus 7 x to the 6th y plus 21 x to the 5th y squared plus 35 x to the 4th y cubed plus 35 x cubed y to the 4th plus 21 x squared y to the 5th plus 7 x y to the 6th and plus y to the 7th. Okay, so this is a little bit faster way of finding what your coefficients are if you're given this triangle. You can also construct this triangle like we talked about, how two terms have to sum to the term that's below them. Okay, so I want you to try number 7 on your own as a checkpoint. We'll check that one together in class the next day.